Okay, so we're going to start building our rasterizer. You can imagine it kind of like this. We have, some points here. You can imagine all these grid spaces as being pixels, right? And what we're going to do is we're going to interpolate between all of these lines, so we're going to interpolate from here to here, and we're going to interpolate, this line, and then we're also going to interpolate this line. Uh, so when we interpolate, and as we're interpolating down, um, you can see that eventually we get to here, and then we'll have to figure out which side, what's on what, um, which side the long side is on, which side the short side is on, so we know how to interpolate here. But when we do interpolate, all we're going to do is we're going to interpolate through here, and then we're going to get the points for both this side of this line and this line. And then we're going to go and, create and draw some color in between both of these lines like this. And you can pretend that they're completely filling in all of these pixels, because I'm not going to color in specifically each one. I guess I could do this, but I'm not doing that. But the only difference between that and what we're going to do is that we're going to leave 1 pixel less on the one edge of the triangle. So we could pick, this edge, I guess, just so that there's no overlap. So when we fill everything in like this, we just leave 1 pixel on the side, so that when, two triangles are touching each other, there's not going to be any overlap or whatever. Okay, so getting into the code here, I have my debugging option. I can set to true or false. True, and I want to show you this real quick. So when I turn that on, you can see I have a red, green, and blue line. These are just helpful for me to see. So red is from point 1 to point 2, green is from point 2 to point 3, and then blue is from point 3 back to point 1. Or you can think of it, yeah, that's how you can think of it. But I'm going to turn that off. Well, actually, I'll leave it on just for demonstration. We have some helpful functions here. This line, get magnitude, and interpolate. Down below, this is our draw triangle function, which takes, an array of xy values, 3 xy values, because you need 3 points for a triangle. We're going to sort those values so that whatever is higher up on our canvas is going to be the first element in the array, and whatever's lower down in the canvas, the lower y value coordinate, is going to be higher up in the array. And if blue is steeper than red, we know that we're going to, by determining this, we're getting the 2D cross product. By doing this, we're going to know that blue is going to be on the left side if blue is steeper than red. And in this case, it's still, I think this still evaluates to true. Well, it does, because then this wouldn't be rasterizing right now. But yeah, this is how we're determining whether or not we can, what side of the triangle we can rasterize from, scanline from what side to what other side. Then we're going from the top of the triangle to the bottom of the triangle, which is coordinate 2y is the bottom of the triangle. We're getting our x value with interpolation here. So x1, this is this left side of the triangle right here, this x1 value, x values for this left side. This is the x values for the right side. And there might be a case where, for example, I can change this. That might not be a good example. There we go. So this is actually on the opposite side. See, blue is on the right side, so I don't have any, I didn't set it up for that. So that's why there's no rasterization happening here. But in this case, blue is on the left again. But you can see the difference here is that we're going to have to interpolate for red for one part and then for green for another part. So that's what this is, to make sure that that x2 is the appropriate values as we're going down our y values here. Then I set, I filled in the rectangle in between those 2 points for each scan line, and I set it a width of 2. I tried setting it a width of 1, but it looks kind of funky. Like, you can see gaps in between each point. So I set it to a width of 2, and I subtracted 2 from here so that we have 1 pixel less on that right side of our triangle, like that. Okay, so I fixed the problem. I changed this up a little bit, so now there's a little statement here. If blue is steeper than red, then we're going to iterate the loop a little bit differently depending on whether blue is on the left or the right side. If it's on the right side, we know we're going to have to go backwards. So instead of going from left to right, we're going to go from right to left if it's on the left, if it's on the right side. And I just changed that here. As you can see right here, we are filling in the triangle when it's on the left side, on the right side, and we are doing it also when blue is also on the left side. I also, as you can tell with this, I used AI to give me an array of triangles that fill the screen, which is triangle chords, and I'm looping through all these triangle coordinates, getting some colors from this high contrast colors array, which I also got from AI because I didn't want to make this myself, just a large list of different colors. And that's how we're displaying all these triangles. Made some more changes here. Because in this for loop, we're going from left to right, and then on this for loop, we're going from right to left, I changed when I subtracted for our gap on the right side, the 1 pixel we're leaving out. So I subtracted 1 instead of 2 because it looked a little funky if I did 2. And then on this side, I'm subtracting it from the initialization of x1 because we're going from right. I'm sorry. In this case, we're going the opposite direction. So it makes sense. And in that case, to go, since we're starting off from the right. And with that subtraction, it looks like, see, I can kind of, with this pink triangle, it looks like I can kind of see a gap here that it's forming. And I wonder if I can really get away from that or not. I'll take that 1 out. And I don't know, it does kind of look better without that pixel. Without me taking out that 1 pixel from the right side of the triangle, so I might just let them overlap. So I figured I'd break down the blue is steeper than red variable in case you wanted to know how we came up with this math here. What we're doing here is actually comparing slopes. So we're comparing the slope right here from 0 to 2, and then we're comparing that to the slope from 0 to 1. And if this slope is greater, then we know that it is on the left-hand side. Now we're going to cross multiply. So we're going to take this part and multiply it by this. Put some parentheses around these to make it a little less confusing. We'll take our equality symbol greater than, and then now we're going to multiply this by this. Oops. We'll get there by this. Put the parentheses in. And there we go. We have the exact same thing that you can see up here. So that's what we're doing. And part of the reason why this works too is because we know that x2, which right here, is going to be greater than x0, so that we're not going to get a negative number in this bottom part, in the denominator of the fraction. If we were going to get a negative number, then we'd have to flip this equality sign. But we don't have to, so it works out. Okay, so that should conclude this video for now. There's a lot more I can do with this, but I'm just going to end it here, and we'll work on more of this later. And something else I want to point out is I'm just doing this so that I can have more of an understanding of what's happening in computer graphics. And this is not what necessarily is actually happening when graphics are being rendered to the screen, because obviously they're going to be using, you'd be using your graphics card for things like that normally, and the operations might be a little different. This is just to have more of an understanding of what's going on. We're using the CPU and not the GPU.